Okay, so now we're going to switch gears a little bit. We're still in the realm of binary compounds, but for objective 4 and 5, we are going to talk about molecular compounds and binary acids. So a little different rules than the ionic compounds, but still easy to do because we're still dealing with just two elements at the same time. So name and write the formula for binary molecular compounds and interpret prefixes used in the names. And name and write the formula for the 6 binary acids. And our essential question is, how are the names and formulas written for molecular compounds and binary acids? And how are those different than ionic compounds? Well, first of all, this is a binary molecular compound. So because it's a molecular compound, it's going to be two nonmetals bonded together. Nonmetals, you remember, share electrons. So we don't have charges to balance. They both want to gain electrons to be happy to get to 8. So because the charges are not balanced, we need a different system. We cannot use what we did for ionic compounds where you balance the metal, the positive metal, and the negative nonmetal, because now we have negative nonmetals bonded together. So we need a new way to determine the number of atoms in each element because we can't rely on charges to tell us. And so for a molecular compound, we have to rely on Greek prefixes. So a Greek prefix is used before the name of the element in the compound to tell the number of atoms. It's really easy to do. Here's our Greek prefixes that we're going to use. We have mono means 1, di means 2, tri means 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. I suggest you get those down in your notes so that you have them to go back to. So when you're dealing with a binary molecular compound, your naming rules, there's 3 naming rules. A Greek prefix is added to each element to indicate the number of atoms of that element. Now remember, a prefix comes before. So you're going to have these words or these prefixes before the actual name of the anions bonded together. The ending of the second element is still IDE, so you still have to change the second anion, that second nonmetal in there, to IDE. And we will always use a prefix, except mono on the very first element. So every single binary molecular compound will have a prefix on it. Both words will have a prefix on it, except for mono on the first element. And these just take some practice. So I've given you some examples here. I have C and I have O. Well, that's carbon and that's oxygen. Well, I have 1 carbon, so that would mean monocarbon, and I have 1 oxygen, so that would mean monooxide, because I still have to change the ending of the second one to IDE. But remember, we don't use mono on the first one, so this is why CO is called carbon monoxide. That tells me I have 1 atom of carbon, 1 atom of oxygen. CO2 is still carbon and oxygen, so monocarbon and dioxide, because I still changed the second one to IDE, but we don't use mono on the first one, so I dropped that, and this is why CO2 is called carbon dioxide. PCl3, I have 1 phosphorus, so that's why it's just phosphorus, and I have 3 chlorines. Well, I have 3 meaning the tri, and then I changed the ending to IDE, so phosphorus trichloride. SO2, sulfur dioxide, to show that I have 2 of them. P2O5, I have 2 phosphorus here, so diphosphorus, and then I still have to deal with changing the ending of the second one to IDE. So the oxygen in this case would be oxide, and I have 5 oxygens, so pentaoxide. I know it's kind of weird to say, but this is diphosphorus pentaoxide. CCl4, I noticed these are all binary molecular compounds, 2 elements, and they're all a nonmetal and a nonmetal, a nonmetal and a nonmetal, a nonmetal and a nonmetal. That's how you identify them. Our last one here, or this next one here, carbon tetrachloride, I have 4 chlorines, so that's where the tetrachloride comes from. Our next one here, I have 7 seleniums, and I have 8 fluorines. So 7 selenium is hexaselenium, and because I have 8 fluorines, that's octafluoride. So the name of this would be hexaselenium octafluoride. So they're pretty easy to do. The hardest part is making sure that you identify, hey, this is a molecular compound. This is a metal and this isn't, or these are two nonmetals bonded together. You just have to be able to use your periodic table and sort these things out. So just to go back to this really quick, when you are naming or writing the formula, it's pretty easy to do as long as you have the right element symbols and you have the right prefix. So I would leave maybe 4 to 5 spaces in your notes for us to do some more practice problems in class with these, and I can answer any questions you might have. Jot those questions down on the left side of your notes, and we can go through some more practice problems. So the binary acids, there are certain binary compounds, when they are dissolved in water, will form acidic solutions, meaning they'll have a low pH. They will release hydrogen and have a low pH. We call these things the binary acids. You can identify them because hydrogen is always going to be the first element. They are binary, and there's only 6 of them. So this is not when hydrogen combines with any element, because hydrogen combines with oxygen and does not do this. There are only 6 cases to where hydrogen will combine with one other element to form a binary acid. And they are HCl, HF, HBr, HI, H2S, and H2SE. You notice the 6 of them. We're going to draw a box around them on your periodic table. We'll do that in class together, so you don't have to worry about doing that right now. But there are only 6 of them, so these can kind of sneak up on you because you might miss them as you're dealing with practice problems that have all these things mixed together. But if you see H first, you need to stop and make sure that it is not one of the 6 binary acids. The naming rules for binary acids are a little different. Instead of writing hydrogen, number 1, instead of writing hydrogen, you will use the prefix hydro, and you'll combine that prefix with the root of the nonmetal it's bonded with. So like here I have hydrogen bonded to chlorine, so hydrochlor with that root parent name. And at the end, instead of using IDE, I will change the ending to ic to imply that it's an acid. If I don't change it to ic, then that does not. If I just leave it as hydrochloride, that doesn't imply that it's the acid. And number 3, I make that all one word. So hydro, then stem of the parent nonmetal, then ic, and then I add acid to the end of it. So HCl is hydrochloric acid. HBr is hydrobromic acid. HI is hydroiodic acid. When you're writing the formulas for them, it's the same as it is for a binary compound. You're going to balance the charges, or for a binary ionic compound, you're going to balance the charges. Hydrogen always forms a 1+ ion. The nonmetal it's bonded with either is a 1- or a 2-, and you just balance accordingly. Which if we go back, you can see the formulas for them. This is a 1 + 1-, that's a 1 + 1-, 1 + 1-, 1 + 1-. But here's a 1 + 2-, 1 + 2-, and you can see I have 2 hydrogens. So here's some examples to write the formulas for. Hydrogen is a 1+, sulfur is a 2-, so I have to have 2 hydrogens, which is why it's H2S. You can do these on your own. We're going to work these out in class, but like I said, there's only 6 of them. So you just work out the 6 examples, and they're basically ones that just kind of sneak up on you and can cause you some problems if you don't pay attention to them. The summary format for objective 4 and 5 is going to be template 1, and we're going to do that in class together. What I want you to do before class, though, is write a level 3 test question on the left side of your notes related to naming or writing formulas for the compounds we cover in objective 4 and 5. So the binary molecular compounds or the binary acids. In class, we will fill in the foldable again. And we're just going to continue working more examples. We're going to do examples on whiteboards again, and we're going to do more example practice problem packets, because the best way to learn how to do this is to do more practice problems. There's a website down here we're going to go to in class that again has more practice problems on it.